Now, if we take a look at the product to sum identities, notice that on the left-hand side of our formulas, we have products. So this first product is cosine A times cosine B, and that's equal to 1/2 the cosine of A plus B plus the cosine of A minus B. Right? Next, we have sine A times sine B. We have its formula. Then we have a mix of sine and cosine. So in the next form, we have sine A times cosine B, and we have cosine A times the sine of B. Notice that from the last example, or from the last section, we can actually take the formulas, we can use them in reverse, and we can modify them. So when we're using the product, the sum, and the sum to product formulas, we're simply taking a formula, right, that fits the pattern of our problem, and we may or may not have to manipulate the formula in order to get the solution. Now, when you're working with the product, the sum, and the sum to product rules, you have to be mindful of the negative number identities. All right, so just to review that slightly. Okay, I'm going to go back to our class for just a second. I'm going to go into lecture notes, and I believe this was in, 9.3. I'm sorry, I believe it was 9.2. Okay, I may just have to write them out. Okay, here they are. They're at 9.1. All right, these negative number identities. So it says that the sine of negative theta, right, that's equal to negative times the sine of a positive theta, right? So keep in mind that we can write a negative angle as a positive angle using the negative number identities. The cosine of negative theta is equal to the cosine of theta. The tangent of negative theta is equal to negative times the tangent of theta. Now in our sum and sum to product and product to sum formulas, notice that we're only dealing with the sines and the cosines. All right, so let's take a look at an example. I think I'm just going to bring up another page here. All right, and I'm going to pull a problem from this section. Let's see, this is, all right, let's take a look at number 1. This is 3.4 problem number 1. We have 14, well, the directions tell us to rewrite the product as a sum or difference. And we have 14 times the cosine of 11y times the cosine of 10y. All right, so that's 14 times the cosine of 11y times the cosine of 10y. So we're asked to rewrite this product as a sum or a difference, right? So we're given a product, and we're looking for the product formula that has some type of cosine times another cosine. right? So I'm going to bring back up the formula sheet. And if I look at my product of sum formulas, notice that we have this first formula, cosine A. I'm actually going to write that down. Cosine A times cosine B. That's equal to 1/2 times cosine A plus B plus cosine A minus B. Right, so notice we have the cosine times another cosine, so this is the formula that we're going to choose. All right, so above that, I guess below that, because we have to manipulate the formula. All right, so we have cosine of A times the cosine of B. That's equal to 1/2 cosine A plus B plus cosine A minus B. All right. Okay, so notice I have the same setup or sort of the same setup. But notice in my formula, right, I could substitute, 11y for A and I can substitute 10y for B. But in the formula, the coefficient for that cosine A, cosine B term is a 1. We need for the coefficient to be a 14, right? So then it would line up exactly. So with that being said, in order to change the coefficient from a 1 to a 14, that means we have to multiply both sides by 14. Right? Whatever you do to one side, you must do exactly the same thing to the other side. Right? So if we multiply both sides by 14, the new formula now is 14 times cosine A times cosine B. That's equal to 7, right? Because 14 times 1/2 is 7. Times cosine of A plus B plus the cosine of A minus B. Right, so notice we've taken the cosine product formula, we multiply both sides by 7. Right. So now that we have the newfound formula, I'm simply going to rewrite our problem under the newfound formula. So that's 14 cosine 14 cosine 11y cosine 10y is equal to 7 times the cosine of A plus B, so that's 11y plus 10y plus the cosine of A minus B, so that's 11y minus 10y. Right? And then we're going to simplify. So this is 7 times, and make sure to keep a parenthesis or a set of brackets, right? Because if not, you would have to distribute that 7, okay, which we're not doing. We're just going to leave it in this multiplied form. So 11y plus 10y is 22y, 21y plus 11y minus 10y is y, so that's plus cosine y, and we have the solution. All right, so notice that you can manipulate the formulas. Whatever you do to one side, you have to do the same thing to the other side. All right, and then notice for my final result, you must include a set of brackets. And I'm also noticing that you must include a set of parentheses for the arguments of your trig functions. All right, so the next thing we're going to do is we're going to look at sum the difference. So in this example, this is similar to number 7. I'm going to just write this out as 3.4.7, and we're asked to rewrite the sum or difference. Okay. Now, believe it or not, the product, the sum, and the sum, the product are some of the easiest formulas to use. They just sort of look scary, right? But once you find the right pattern, you may have to manipulate, you may not have to manipulate, but once you find the right pattern, it's just a matter of substituting and simplifying. So here we have cosine of 4y plus the cosine of 2y. And we want to rewrite the sum or difference as a product. So we're going to look at the sum and difference formulas, and we're going to find the one that fits a cosine plus another type of cosine. All right, so looking at the formulas, we see that the third formula is a cosine plus another cosine type formula. So I'm going to write that down. Cosine A plus cosine B is equal to 2 cosine A plus B over 2 times cosine A minus B over 2. All right, so I'm actually going to write that above the formula. So we have no need to manipulate in this particular formula. So we have the cosine of A plus the cosine of B, right? So we're going to substitute A for 4y. We're going to substitute B for 2y. That's equal to 2 times the cosine of A plus B over 2 times the cosine of A minus B over 2. All right, so substituting into the formula, we have 2 times the cosine of 4y plus 2y over 2 times the cosine of 4y minus 2y over 2. Right, we're going to simplify that down some, and we have 2 cosine 6y over 2 times the cosine of 2y over 2 for a final result of 2 times the cosine of 3y times the cosine of y. Right, so pretty straightforward. Now, in some instances, you may have to use the negative number identities, right? Because you want to make sure that all of these angle measures are positive. All right, so let's take a look at one that requires that. All right, so this is similar to problem number 8. So this is 3.4.8. And we're asked to rewrite the sum as a difference, or the sum or difference as a product. So here we have the cosine of 4z plus the cosine of 10z. Right, so we're going to use the same formula that we did in the previous example, right? Cosine 4y plus cosine 2y. So the formula says that the cosine of A plus the cosine of B, right? So here again, we're going to no need to manipulate the formula. We're simply going to substitute A for 4z and B for 10z. Right, so that's 2 cosine A plus B over 2 times cosine A minus B over 2 so that's 2 times the cosine of A, which is 4z, plus B, which is 10z over 2, times the cosine of A, which is 4z, minus B, which is 10z over 2. Right? And if we simplify, we have 2 times the cosine of, well, 4z plus 10z is 14z over 2, and 14z divided by 2 is 7z, times the cosine of 4z minus 10z, which is negative 6z, and negative 6z divided by 2 is negative 3z. From our negative number identities, the cosine of negative theta is equal to the cosine of positive theta. So I think they may let you get away with this, but technically you should write this out as the 2 times the cosine of 7z times the cosine of 3z. Okay, I'm just scrolling down through some of the problems. All right, and I think these things are pretty straightforward in this section. I believe there was 1 or 2 where you may have to manipulate a formula. I think that was problem number 1. Okay, problem number 2, problem number 3. I believe the first 3 problems you had to manipulate a formula. Right, but the rest of the problems were pretty straightforward. Let's see, evaluate the sum of difference. I'm just making sure. Okay, some of these things. Okay, well, let's take a look at this one. This is similar to number 11, 3.4, number 11. And we're asked to evaluate the product using a sum or difference. And it says to leave in terms of sine and cosine. Right. So we have 2 times the sine of 19 degrees times the sine of 18 degrees. right? So we want to rewrite this product as a sum or a difference. So I'm going to look at the sum or difference products, and I'm going to look for the sign times the sign pattern. All right, so looking at the product sum formulas, I see that the very second formula is a sine A times the sine B. All right, so that formula says sine A times sine B is 1/2 cosine A minus B minus cosine A plus B. All right. So we do have to modify our formula in this instance. So I'm just going to rewrite the formula. So it's sine of A times the sine of B. That's equal to 1/2 times the cosine of A minus B minus I'm just making sure that I have the right formula. Yeah, cosine. So that's cosine A minus B minus cosine A plus B. All right, so in our problem, we could substitute A for 19, we could substitute B for 18, but notice our coefficient is 1. So in order to make the problem match the formula exactly, I'm going to multiply both sides of the formula or this equation by 2. Right. So if I write out the left-hand side, I have 2 sine A sine B, right, which now fits our formula exactly. On the right-hand side, 2 times 1/2 is 1, so I'm left with cosine A minus B minus cosine A plus B. And now I'm going to substitute. Right, I'm going to substitute A for 19 degrees and B for 18 degrees. Right, so that's the cosine of, well, 19 degrees minus 18 degrees is 1 degree minus the cosine of A plus B. Well, 19 plus 18 is 37 degrees. All right, and that should be our solution.